Okay, so let's talk Pythagoras. What I've got here is a sketch. I'm going to start with the basic derivation of the Pythagorean theorem, and then we'll move on to the trig version of that. So this is a square, a by a, another square, b by b. So this blue part represents a squared and b squared. And I put a little triangle here, and this would be a, b, and this would be the side c. So what I'm going to do is I'm going to take this triangle, I'm going to kind of study it a little bit. So I'm going to switch out of this mode, grab this triangle here, and I'm going to copy it. I need 4 of them. Now, the first thing is that if we think about the angle at the top and the angle at the bottom, there's a connection between them, which is important. That say this is alpha and this is beta. Well, what we know about alpha and beta is that they have to add up to 90 degrees. So if I take one of these guys and I rotate it, I'm going to clear this off here. And I'm going to move this. I want to be careful not to resize this, but I'm going to rotate it. So basically, I'm going to put this guy in a position where he's right up against this guy. Now, what's important about that is that I've made a 90-degree angle because this is alpha, and this side, this corner is beta. Well, alpha and beta are 90 degrees, so this is beginning to make a square here, right? This is a 90-degree angle, and I'm going to keep going. Now, it doesn't work out perfectly. I mean, there is going to be a gap here when I put these 4 shapes together. But I'm going to keep building my square. And importantly, of course, this square has a side of C, which of course is the C squared value. All right. So this is C squared, okay? So what do we know about, let me just clear all because I don't think I need any of this stuff. Okay, so what do we know? We know this is C, we know this is C. We know this long side is A, this short side is B. That means that this piece here must be A minus B because it's this whole side here minus this side here, right? And that's the same on each side. So this is A minus B, this is A minus B, this is A minus B. In other words, this is a square, which is A minus B by A minus B. So now let's put it all together. This big square is C squared, and it's equal to 4 of the area of the triangles plus the area of that square inside. Okay. What is the area of a triangle? Well, this was A and this is B. Area of a triangle is 1/2 base times height. So it's a half AB. So this is 2AB, 4 times a half AB, plus A squared minus AB plus B squared. Well, lo and behold, 2AB minus AB is nothing. So I've got A squared plus B squared. There it is, the Pythagorean theorem. Now, of course, where we go from there is, and I've shown you this already, we can turn that into the trig version, and there are actually multiple trig versions. If we start with A squared plus B squared equals C squared, and I divide everything by C squared, then I have A over C squared plus B over C squared equals 1. But if I go back to my triangle, A, B, C, in terms of the angle alpha, A over C is cosine alpha, and B over C is sine alpha. So I get cosine squared plus sine squared equals 1. Or sine squared plus cosine squared equals 1. Okay. Now, if I divide everything by cosine squared, so this is version 1, then I divide everything by, say, cosine squared, I get 1 plus sine over cosine is tangent, and 1 over cosine is secant. This is a second version of the Pythagorean theorem in trig. And you guessed it, if I divide by sine squared, I get the third version. Cotangent squared plus 1 equals cosecant squared. So those are 3 versions of the Pythagorean theorem. We use these in different situations, but in some problems, we can use, we've already seen questions where we started with a sine or a cosine value, and then we can use that now to figure out the other value. In fact, we can use sine or cosine to figure out any of the 5 values by using the Pythagorean theorem. We can also do it through the regular Pythagorean theorem, finding the missing side, using the angle, but it's just another option for us to solve problems. And in trig, it comes up big with trig substitutions because sometimes it's harder to integrate one form of something, and we can use triangles to kind of manipulate forms and create different things and do some cool integration techniques using trig. Okay, so that's the Pythagorean theorem in straight up A, B, C, the sides, and then also converting it into the Pythagorean theorem in trigonometric terms. One thing I would say about proofs and derivations is, there's a point where you should start to kind of try to make sense of those things, and you're kind of pushing yourself eventually, depending on how deeply you go into mathematics, to be able to produce them on your own. To think about how it is that some stated fact is true, because a lot of times what you get is a statement of something that's true without an explanation of why. And in mathematics, often the why is a very kind of intriguing and interesting part. At lower levels, often people are like, well, it's too complicated. You don't want to, explode your mind. Like that Pythagorean theorem derivation that I did, I don't think it's too complicated, but it definitely involves some skills like binomial multiplication, just the geometric kind of identification of the angle measurements, putting them together, and then the difference of the sides. Nothing too crazy complicated, but it's always a question in terms of teaching, when how far do you go and how much do you try to prove kind of absolutely versus just kind of throwing it out there and letting people use it. So I definitely do a little bit in this class of showing you some derivations and things where they come from. Other times just be like, this is like, as we get to the conic section part, some of it's interesting, and then some of it I leave to you to do as an exercise. Okay, don't be afraid of it. You got this.